In this lesson, we will be going over the visual representation of something called completing the square. So completing the square is just another math mechanic, kind of like factoring. Okay, so let's review how we would factor x squared plus 4x plus 3. We know that we got to find two numbers that add up to the middle number that multiply to 3, and we know that those two numbers are 1 and 3. And so that gives us x plus 1 times x plus 3, correct? And we also went over the visual representation of this. We remember that we could set it up using tiles. We have an x squared term, we have 4 x's, and then we have 1, 2, 3. So we get x plus 1 plus 1 plus 1, so there's x plus 3, then we have x plus 1. So that was the visual way to do this, right? And so we can also do it with x squared plus 4x plus 4, right? We'll find two numbers that add up to 4 that multiply to the last number 4, and that's 2 and 2. Right, and so that gets us x squared plus 4x plus 4 becomes x plus 2 times x plus 2. And note, this is going to be important for the next couple, but x plus 2, just like we just did on the last assignment, we can change that to x plus 2 squared. Right, so whenever we have the same number like this, it becomes important because these can be converted into vertex form, right? Because when it's not the same number, x plus 2, like over here, x plus 1, x plus 3, we can't convert that one, right? So these perfect squares are important, right? And so that's kind of where this completing the square notion comes from, because we have a square here, a perfect square. We have x plus 2, we have x plus 2. So whenever we have a square like this, that enables us to do this conversion process to actually get it into vertex form. Okay, so that's kind of the basis behind what completing the square means. And so what if we had to graph an equation like y equals x squared plus 4x, right? Like when we factor this, it just becomes y equals x times x plus 4. That doesn't help us get in vertex form, right? This does not convert to x plus 4 squared like that. It does not do that. So here, we have to graph this, but we can't. We don't have enough information, right? So since this equation, it's not in vertex form, so as of now, we are unable to find the vertex. We're unable to graph it. Okay, and so doing something called completing the square is going to allow us to graph something like this. Okay, so we're going to complete the square with x squared plus 4x. We have x squared, and we have 4x's. And we set up a square. So we think by completing the square, right, we want to figure out what number here is going to complete the square. Right, so we think how many numbers, how many little squares are going to go in these boxes. Hopefully you're thinking the number 4, because now we have a perfect square. So in order to complete the square, we get plus 4. Okay, so the completed the square equation is x squared plus 4x plus 4, and this is the visual representation, and we're also going to go over how to actually calculate this without using the shapes every time. So let's get 8x squared plus 8x, right? Once again, we would not be able to graph this, so we want to try to complete the square so we can actually convert it a little bit, but we're just going to worry about completing the square right now. So we have x squared plus 8x's, and now we think, all right, how many squares are going to be here? Right, well, looks like there'll be 4 here, 4 down, so looks like there's going to be 16, right? So x squared plus 8x plus 16, that is what it looks like after we've completed the square. And so we're not going to do this today, but tomorrow we're going to see like this. We're going to factor into x plus 4 times x plus 4, and then it becomes x plus 4 squared, right? But we're going to get to that tomorrow, okay? And so now we don't always have to want to write out the tiles. Okay, so the way that we calculate this by hand instead of just visually, okay, in order to get this 16, okay, so I'm going to show the calculation on how we get this number 16 without making all these shapes, okay, is we are going to do this. This is how you complete the square. This is very important, so highlight this if you need to, right? In order to get that 16, we have to do b. We find the number b, divide it by 2, and then square it. So the b in this number is the number 8, So we're going to take that number 8, we're going to divide it by 2, and then we're going to square it. 8 divided 2 is 4, and then 4 squared is 16. So that is how you show the work using b over 2 squared. Let's finish it off with one last example. We have x squared minus 10x. So if we were going to show this visually, which we're not, we're just going to do it by b over 2 squared, it would look like this one. And you don't have to write this if you don't want, right? So we have 5 on each side. We have 5 on this side. So that's going to represent the 10 x's. And then basically when we're completing the square and thinking what number this is, that is the numbers here. Okay, so instead of moving the tiles around, let's just do b over 2 squared. And so the b is negative 10. So we get negative 10 over 2 squared. So that gives us negative 5 squared, which is 25. So when we complete the square, it's going to be x squared minus 10x plus 25, meaning there would be 25 little squares in this section. Thank you for listening.